In this video, I'm going to talk about how to graph a parabola that's written in standard form. You can watch the other video on how to graph a parabola written in vertex form, but it's pretty much the same steps as graphing a standard form parabola and a parabola in vertex form. The first thing we need to figure out is the vertex and the axis of symmetry. Well, when we're looking at standard form, this isn't as easily accessible as vertex form. We're going to have to work backwards a little bit in order to find our vertex. Well, the first thing we know that when we look at any sort of standard form parabola, that the axis of symmetry is the line x equals negative b over 2a. And if you want to figure it out, this is derived from the quadratic equation, negative b plus or minus the square root of b squared minus 4ac over 2a. You can figure that out. But we're just going to need to know this for right now. So if you don't want to look into that, just memorize this formula. And so we use this formula in order to find our vertex. So if you remember when we had h and k, that this coordinate was the number that went here from the axis of symmetry. Well, that works when we go backwards. So the x-coordinate of my vertex is negative b over 2a. And that makes my y-coordinate be f of negative b over 2a. Basically, we take negative b over 2a, we plug it into the equation, and we get out the y value. So this is the new information we're going to use in order to graph this problem. So here's what I have. I have y equals x squared minus 2x minus 1. And I want to go ahead and graph it. So the first thing I'm going to do, in this case, I can't just look at it and say, oh, my vertex is here. I'm going to start out by finding the axis of symmetry. Well, my axis of symmetry is, I'm going to write it down again, negative b over 2a. So in this case, b is negative 2. So it's going to be negative 2 over 2 times, my a value in this case is 1. So it's going to be negative 2 over 2 times 1, which if we do that, negative 2 is just 2. So that gives me 2 over 2, which gives me a value of 1. So that is the x-coordinate of my vertex, is 1. So now what I'm going to do is I'm going to find the y-coordinate. So I'll do that over here, and I'll make sure I do that in a different color. So I'm going to find what is the value of y when I plug in 1. So I'm going to do y equals 1, and I'm going to put parentheses just to get in the habit, 1 squared minus 2 times 1 minus 1. So let's see, that gives me 1 squared is 1, minus 2 minus 1, and that, well, let's see, those cancel out. That gives me negative 2. So there is my y-coordinate. So that took a little bit of extra work compared to vertex form. But from here on out, it's going to be the same procedure. So I'm going to go ahead and plot my vertex. So that's 1, negative 2. Then I'm going to sketch my axis of symmetry. And generally when you sketch these, you want to make them dotted lines. And it's a vertical line that goes through the vertex. And if you didn't see the last video, this cuts the parabola into 2 pieces, so that way when I fold it over, each side of the parabola lays on top of itself. That's what it means to be symmetrical. So from here, I'm going to pick 2 values. And I'm going to pick 2 values on the right of my axis of symmetry, 2 x values. So I see here that x equals 2 is on the right, and I also see that x equals 3. And I'll get to x equals 3 in a minute when I do the calculation first. Put it right here. So what I'm going to do is I'm going to take that and I'm going to plug it into my function. So I'm going to find f of 2. So basically what happens when I plug 2 into this equation? So let's see. 2 squared and then negative 2 times 2 minus 1. Well, let's see, that's 4. That's minus 4. That's minus 1, and that gives me a value of negative 1. So I now have the ordered pair 2, negative 1. So I got 2, negative 1. And then I do the same thing with 3. So I have 3 squared minus 2 times 3 minus 1. So let's see, 3 squared is 9 minus 6 minus 1, and that gives me a y value of 2. And so now what I'm going to do is I'm going to plot that point as well. So I've got the point 1, 2, 3, 1, 2, and there we go. And so if you didn't watch the last video, from here I'm going to use the property of symmetry. Since this line cuts it in half, I can use that property to reflect this point across the axis. So it's 1 away, so I go over here, plot 1 away. Let's make that a different color. 1 away. So that way when I fold it on top of each other, this point and this point overlap. Same thing for this one. It's 1, 2 away from my axis, so I reflect it. I go 1, 2. Now we go ahead and try and make as smooth a curve as possible. And again, I apologize if this isn't a smooth curve. I'm going to get it as close as I can. You should be able to get it a lot closer on your paper. And so there's my parabola, and obviously you should see that it should go through this point as well. I was trying to get it as close as I could. Now the last thing I want to talk about is minimum and maximum. Well, on the last video we talked about whether or not it's a minimum. In this case, this is a minimum of my graph, and it's located at my vertex. My vertex is the point 1, negative 2. And you could be wondering, well, how do I know if it's going to be a minimum or a maximum? Well, if it opens up, the parabola opens up as a U shape or is like a vert ramp, then it's going to be a minimum. That is the lowest point on my graph. Now, if I have a graph that opens down, it's going to look like a roller coaster. And so the top of my roller coaster is going to be my maximum value. So in this case, I have, looks like a bowl or a half pipe. So this is my minimum value. And so we say the minimum coordinate, well, it's located at the point 1, negative 2, which happens to be my vertex. So my minimum value, in this case, is negative 2. So in this video, you've seen how to graph a parabola that's written in standard form. We start out by finding our axis of symmetry, plugging it into the equation to find the y-coordinate of my vertex. So it gives me 1, negative 2. We plot our vertex, sketch our axis of symmetry, pick two values, so two x values that are on the right, and you could do it on the left, it doesn't really matter. And then we go ahead and reflect them across our axis of symmetry. And then we discuss how to determine whether or not we have a maximum or a minimum. Bowls are minimum, roller coasters have maximums. And that's it.